what mystery of the Mars another team does. Launch services, everything and the launch pad, period quota, someone has to ensure this irrespective of the weather conditions and other things, launch takes place properly, launch service is taken care. Then the ground system, once you launched, everything is controlled, monitored and controlled to ground system, it needs enough hardware, infrastructure, ensure that should be there. Not only that, mission plans, I told manual human errors, that comes in this, mostly from here. You launch it here, satellite is going, and you have the ground systems available, but still, you need a very good mission plan, how to communicate the satellite, how to operate the satellite, how to transfer the orbits from one to another. In case of a problem, what you are supposed to do, everything should be there a priori. You cannot keep working it out in the real time. Okay, things should be there, done and there. So mission plans and operational plans will be available. Everything we are doing, such that science comes out. The science team also will be ready. Once it Mars goes there, and the data keep coming, try to derive from science. Chandryaan showed there's water on the moon because science team was working around that time. So all these things independently should be done. Independent doesn't mean disjoint. Just to be collectively come together, such that don't look like a puzzle, jigsaw puzzle. It's not jigsaw. Finally, the Mars rocket mission has to come. Everybody works in segregation will come. That's what really happened. How it happened? Now you look at here one by one. The team, the instrument team, science team, overall going for the moon. That is your team works. What we going to on the Mars? What really you want to look for? Okay. Now you think for particular this orbital mission. What all you can do when you going around the Mars? You are going there and going around the Mars. We are doing what all we can do from there. We can do atmospheric study. Mars contains the atmosphere. We can do atmospheric study. If you go back to Earth. Because once upon a time we thought Mars also was something similar to that. But today its atmospheric conditions are different. Why that's happening, we must be able to unravel the mystery. We should have some couple of instruments. And these are all the 4 instruments that have been come out across the laboratories of across India. And we selected 2 of them. One is for how escape process of Mars upper atmosphere. That is, it's still escaping. Mars atmosphere is there, but still it is escaping out into the outer space. What is the mechanism? Why it's happening there? To understand, we have a level of photometer going there. That will say that basically the deuterium, that is hydrogen's isotope, the hydrogen, the ratio try to get, and from there try to understand what is the escape process happening there. And another thing is detection of water has been already unambiguously seen. So we didn't want to duplicate here. But detect the presence of methane. I think even today, question marks are big there. Big question marks are there. We want to understand, unravel the mystery as it's civil force. And another thing is plasma and particle environment studies. For that, the instrument goes. And we have another instruments understanding the surface imaging studies. Even from remote sensing, you can understand what the surface features with respect to optical imaging, as well as map the surface composition with the mineralogy. The thermal imaging sensor will be able to tell from that resolving the thermal energies. I have to understand what is the mineral composition of the Mars. This is possible too. So these are all the instruments have been, what are all green, the instruments have been selected, the 5 instruments have been selected to accommodate in the Mars orbiter. This science team is doing. Parallel engineering team is trying to make the satellite, how the configurations, okay, on the drawing board, on the existing CAD systems. We are trying to work it out, how, what systems can be recorded, and such that it takes care of the mission from all the way from Earth orbit, which PSLV leaves around their elliptical orbit. From there, it has to take all the way to the Mars. So required systems have to be accommodated, and this system is being configured like this here, from the Mars orbiter satellite. And that basically, when you put it together, it will look like this. But still, we have to ensure this is the overall system it talks about. But still, it gives the riders. Propulsion system should be more reliable. What are the lessons learned will be accommodated here? Power, that is the solar power, is the one which gives the primary power for the satellite. But you look at here, around the Earth, okay, now you assume yes, the solar constant is 1, that nearly 1350 watts per meter square is the solar constant which comes near Earth orbit. But when you go to the Mars is much beyond, okay, and from when the nearly 30 to 40% of the sun energy only reaches the Mars. So around the Mars, the solar energy is coming nearly 1/3. You have to account for solar panels. Here it generates more power, there it generates less power, where has to accommodate properly. But another issue is similar to about thermal. Sun loads are different. How it's getting heating source is going to be different. And accordingly, even look at the solar panel, whatever you have seen the solar panels carrying. But you will be optimizing a particular temperature, around the range of temperature, it gives a maximum power. Your IBA you take it here, maximum power called DA, I can that need. that knee is particular to particular temperature work. The temperature is going to vary from Earth to Mars. Okay? How to accommodate for here is to ensure that engineering part is coming through. Another thing is autonomy. Spacecraft, normally typically we are, whatever the launch, rockets we launch, we will be able to keep either from near India, we have a stack and ground station. We have the continuous watch of the satellites. And whatever something is happening, you are monitoring here, almost in real time. You will have to react in real time. Almost real time, it's hardly few milliseconds time will be happening there. Similarly, from master control facility, your satellite is not more than 36,000 kilometers. Their satellites are controlled by the INSAT geosat missions. And again, the time delay is hardly few hundred milliseconds. But we are talking about a system which will near the Mars, it will be near 200 million to 400 million kilometers. En route is keep on varying. That means there will be a time frame where will be the two-way time, two-way communication will be as high as 400 minutes, or 40 minutes. Okay, 20 minutes signal to reach here, and for immediately you react also, it goes another 20 minutes to go. That means something happened to the satellite, 40 minutes later you will be reacting. Impossible to do that. Okay, by the time satellite would have come to the problem. So you should have enough autonomy such that satellite understands what is the problem, localize the issue, and try to identify and reconfigure the system such that it works autonomously possible, as much as possible.